How can you compare fractions? Think about this question during the lesson. Shauna walked 5/6 of a mile. Tom walked 3/4 of a mile. Which is greater, 5/6 or 3/4? What are some words that are a signal for you to compare numbers? How would you compare these two fractions? You would compare the numerators. Can you compare the numerators of 3/4 and 5/6? No, because the denominators are different. What symbols do you use when you compare numbers? When you compare numbers, you use the following symbols: less than, greater than, equal to. When fractions have different denominators, what should you do before you compare them? When fractions have different denominators, you should write them as equivalent fractions using the least common multiple, LCM, or a common denominator. One way you can find the least common denominator for each fraction is by writing the multiples of each denominator. What are the multiples of 4 and 6? Let's use 12 as the common denominator. What will the numerators be? The numerators are 10 and 9. Multiply the numerators and the denominators by the same number to get the equivalent fractions. Now, compare the fractions. 10/12 is greater than 9/12, so 5/6 is greater than 3/4. Another way that you can find a common denominator is to multiply the denominators. What is the answer? You can use 24 as the common denominator. What will the numerators be? The numerators are 20 and 18. Now compare the fractions. 20/24 is greater than 18/24, so 5/6 is greater than 3/4. Shauna walked a greater distance than Tom. When might you want to use the second option to find a common denominator? You might use it when the denominators are small and easy to multiply. Now you know how to compare and order fractions.
Let's talk about comparing and ordering fractions. Now, when we're comparing fractions, basically it's a fancy way of saying which one of these fractions is bigger, which one is smaller. So we want to compare them. Now, there's a couple different ways that we can do this, and I'll show you a few. And the reason I'm going to show you more than one is because it's important for you to know different steps of each way, because we're going to need to know these steps when we're working with fractions later in this unit and then in our next unit. So basically I have two fractions here. I have 4/5 and 2/3. And I want to figure out which one of those fractions is bigger. Now, there's a couple different ways that I can do this. The first way that they showed us in the animation is they show us to list all of the factors of 5 and all of the factors of 3, all of the multiples of 5 and all of the multiples of 3. And when we find a multiple that they have in common, we can then use that to create new fractions. So equivalent fractions. So if I find the multiples of 5, here's what I do. I'm going to write 5 and I'm going to write 3. And now what I want to do is I want to count by 5 and count by 3 until I find a number that they have in common. So what I'm going to do is I'm going to start with my smaller number. I'm going to start with 3, and I'm just going to count by 3s. I like to do it like 5 times. There's no set number, but hopefully within the first 5 to 10 multiples, you can find a number that they share. So what I'm going to do is I'm going to keep counting by 3 until I find a number that I either know is a multiple of 5 or until I get to 3 times 5. Now I counted 5 times. I recognize, because I'm pretty good at multiples, that 15 is a multiple of 5 as well. And I know that because if I count by 5s, there it is. 15 shows up there as well. So I know that they have a common multiple of 15. Basically what that means is that I can multiply both of these fractions by a number so that I get 15, so that I get 15 as a denominator. Now here's what I want to do. I want to now create my equivalent fractions, and here's how I'm going to do this. What I want to do is I want to look at 4/5, and I want to say, well, if I go from 5 to 3, what did I multiply 5 by in order to get to 3? And you don't even have to figure it out because you can look right down here. How many times did I count by 5s till I got to 15? That was 1, 2, 3 times. So I multiplied my 5 times 3, and I got 15. If I multiply the denominator by 3 to get 15, I have to multiply by my numerator by 3, and that will give me 12. So an equivalent fraction to 4/5 is 12/15. Now what I want to do is come over here and do the same thing with 2/3. I want to figure out how many times did I count by 3 before I got to 15. And again, 1, 2, 3, 4, 5. Just count the number of times you did this. Now, if I multiply my denominator by 5, I have to multiply my numerator by 5, and I end up with the fraction 10/15. Now that these fractions have the same denominator, I can compare them and figure out which one is bigger. I don't even have to look at my denominator. You're going to focus in on the numerator. Which one's bigger, 10 or 12? Well, 12 is bigger. So 12/15 is bigger than 10/15, which means that 4/5, because that's what 12/15 went with, 4/5 is bigger than 2/3. Now, that's a important way to understand how to figure out how to compare fractions. The reason being because as we continue to work with fractions, you're going to need to find least common multiples, which is the smallest multiple they have in common. A longer way that we can do it that is a little bit more simple and might help those of you who are confused. I'll show you a kind of trick. Now this trick is helpful for you to get 2 equivalent fractions. It's very helpful for you to figure out equivalent fractions to 4/5 and 2/3 that have the same denominator. But the only problem is, and you'll see this when we work later in the unit with fractions, it's not always going to give you the smallest denominator, and it's very important that we have the smallest denominator when we're working with fractions, but we'll get to that in a little bit. Now here's the little trick that I'm going to teach you. What we're going to do is we're going to do some semi-fancy multiplying. In order to create 2 fractions that are equivalent, that have the same denominator, I'm going to cross multiply. So I'm going to multiply in an x, and then I'm going to multiply my bottoms. So I'm going to multiply in an x, and then multiply my bottoms. Now I'll show you what I mean by that. Let's first cross and crisscross kind of like an x. So I'm going to draw the first leg of my x, and I'm going to multiply the 2 numbers that I connect. I connect 4 and 3, so 4 times 3 is 12, and I want to write that above the top number. The top number was 4. 4 was on the top, 3 was on the bottom. So I'm going to write that 12 on top. Now I'm going to multiply the other cross, the other leg of my x. I do 2 times 5, which is 10, and write that above the top number. So I have my new numerator. I have 12 and I have 10. And in order to find out what their denominator is, I'm going to multiply the bottom numbers together, and I get 15. So now I end up having two equivalent fractions. I'm going to put these two pieces together, and I get 12/15. And I'm going to put these two pieces together, and I get 10/15. Now, if you remember, those are the same fractions we came up with before. It was just a little bit more basic. It's up to you whether you want to skip count by 5s and 3s and see which one they have in common, or if you would rather remember to cross multiply and then multiply your denominators. Either one is going to get you the right answer. The only reason that this method is not always the best is because sometimes you're going to end up with denominators that are too big, and then you're going to have to do some simplifying. And we'll kind of work on that when we get into the unit a little bit later. Let's try another problem. I personally like the last method. The last method that we worked on requires you to be good at simplifying fractions, but I think it's a little bit more direct and there's less steps. So let's try that method. We're going to do 7/8 and let's do 6/7. I need to figure out which fraction. Actually, let's do 5/8. 5/8 and 6/7. Now I need to figure out which one of those fractions is bigger. I'm going to compare them. Which fraction is bigger? The first method that we learned in the animation was to count by 8, count by 7, and find the first number that they both have in common. What I'm going to do, since it's more straightforward, is I'm going to cross multiply and then multiply my bottoms. All right? Let's try that. So I'll show you what it looks like. Same thing. We're going to multiply crisscross. So I'm going to make an X. I'm going to make my first leg of my X and multiply the two numbers that connect. I have 5 and 7. So 5 times 7 is 35. I'm going to write the 35 above the top number, which was 5. So 35. All right. Now I'm going to cross multiply my other two numbers so I make an X. So crisscross or diagonal, I'm going to get an X. I have 6 times 8. 6 times 8 is 48. Write that above the top number. And now to figure out a common denominator, all I do is multiply 8 and 7 together, and I get 56. Now I just have to put these pieces together. My denominator is the same for both numerators. I have the numerator 35. Put these pieces together, 35, 56, and 48, 56. And all I need to do is say which number is bigger. I know 48 is bigger, so 6/7 has to be the bigger fraction. It has the 48 above it. It's a little bit more simplistic and a little bit more straight to the point. It will cause you problems later down the road, though, because you need to get really good at simplifying. So we'll practice these methods when we get further into this unit and the next unit, but I want to show you this method because it's a little bit more straightforward and basic. Go ahead and practice some on your own. Remember, the important thing is to cross multiply and then multiply your denominators. And then you'll end up having two new fractions, and you just need to figure out which fraction is bigger. Now, just a tip before we wrap up. If you're working with a mixed number, just a tip that when you are working with a mixed number, you can't compare them, or you shouldn't compare them unless you have improper fractions. So you'll want to turn your mixed numbers into improper fractions in order to compare them. Remember, in order to do that, multiply down. 1 times 3 is 3, and add up. 3 plus 2 is 5. Keep your denominator. So 1 2/3 written as an improper fraction is 5/3. Go ahead and practice some problems. Good luck, and let me know if you need any help.